So as we move into our feature presentation today, we will be discussing the sensors and the control systems used to communicate with the Fieros electronic control module. This knowledge is useful background information in diagnosing drivability problems like perhaps a rough idle or something like that. Our presenter for this meeting is Joe Aranki, who's the program coordinator for the Automotive Service Technology Department at the College of DuPage, which is a local community college here in Northern Illinois in Glen Ellen. Joe is an ASE certified master technician as well as an experienced educator. And we'd like to thank N.I.F.E Activity Director Art Hall for organizing this event for us. And again, at the conclusion of this presentation, feel free to stick around for some updates from events from Scott Campbell about some events that are coming up, as well as kind of an open chat function at the very end. So without further ado, Joe, can I ask you to take on over?
All right, so I hope everyone can see my screen here now, right? So, okay, well, thank you for having me. I just want to start by saying that we at the automotive program at Glen Ellen, we cover this topic basically over 3 semesters. And there are several classes. So basically what we do in a year and a half, I'm trying to condense down here to less than an hour. So there's going to be some stuff that we leave out, and it's just basically meant to be an overview. You know, each one of these sensors, you can get into much more depth, and, you know, the whole process of input output, you can, you know, study a lot deeper. But okay, so let's start with, what's my car thinking? Oh, it's not advancing. Why is it not advancing? Oh, there we go. Okay, so what did my car always think? You know what? And obviously, you guys know that things used to be mechanical. So even things like there used to be a cam that would open and close points. You may have heard the term points. That would open and close the primary ignition system to allow that field to build up and then collapse ultimately and fire those spark plugs. So all of these things used to be very mechanical, using Bernoulli's principle to induce fuel and, you know, in the induction system. So that obviously changed, right? So as electronics and computers started to incorporate into vehicles, does my car think? You know, does the car think? And kind of, you know, but basically it's all just pre-programmed. It's just pre-programming, and we'll talk more about mapping, and it's about if-then functions. So if this happens, then I'm going to do this, you know, and there's just a lot of that. So it doesn't really think, but somebody's got to be responsible for making those decisions, and that's what the ECM does. So if so, what is my car thinking? Why is it thinking it? And basically, it's all about maintaining that stoichiometric 14.7 to 1 ratio of air to fuel. I mean, that's basically why we do all of this. With the mechanical stuff and all the variables that a vehicle runs into, temperature, load, you know, road conditions, all of these variables, it's virtually impossible for mechanical systems to respond to that and make corrections. So by having this, you know, electronic system, by having a PCM and sensors and actuators, we can now control these things. But the reason we do all of that is to maintain this stoichiometric, or what they call lambda, of air to fuel ratio. So it's important to note that when I was coming up, 5 miles per gallon was a thing. I mean, right? I mean, now you can get cars, which I think Fiero is one of the more fuel efficient cars, but you can get cars as high as 50 miles per gallon. I live north of Rockford, and I commute to Glen Ellen. I think it's 93 miles one way, 180 miles round trip. I would need a lot of fuel to go there and back if I was only getting 5 miles to the gallon. So there's advantages and disadvantages to all this, right? I mean, we don't like all the complexity, but there's an advantage. So, and this chart just shows roughly that these variables that I was just mentioning, what happens to the fuel ratio when these things start, when these things occur during startup, during warm up, accelerating. So we're trying to constantly maintain that 14.7 to 1 as these variables come in. So again, it's all about input and output. So that whole if and then is based on what it's getting and then what it has to do to correct with that. So this is a concept that I talk about with the students a lot. So in your body, if you've ever touched red hot metal, glowing red hot metal, if you've ever touched it with your hands, inside your body, what exactly happens? And as you know, we have nerves inside that will, through our nervous system, it will report that we are touching something that's hot to our brain, right? It will report back to the brain that we are touching something that's very hot and is causing damage. So the brain will decide what is the course of action to take now. What should I do with this information that I'm getting? Now, the nerves can't do anything about it. They can only tell the brain, what's going on. The brain itself cannot actually do anything about it. All it can do is make the decision and then send an output through this nervous system, through this network, to your muscles, right? To your muscles, and it'll say contract, move away from this hot thing. So this triangle is really important in the understanding of the way the car does it, because in a car, if you have something like an oxygen sensor that is sensing oxygen in the exhaust stream, it's watching that 14.7 to 1 ratio. And if it sees, hey, there is too much oxygen that's in this exhaust stream, it will then, on wires, report back to the PCM and say, hey, this is what's happening. I'm seeing too much oxygen. So then the PCM will decide what to do with that information. The oxygen sensor can't do anything about it. The wires can't, even the computer can't do anything physically about it, except for make the decision and send out a signal on wires again to some kind of an output. And then in this case, it would be a fuel injector, and say, hey, there's too much oxygen. Let's put more fuel inside, when we fire, let's dump more fuel in. Let's lengthen the pulse width and effectively having more fuel. So this triangle is the same in our bodies, in the vehicle, and it's important to our understanding. Now, going back to the body one, what happens if that triangle breaks down? What happens if you might have heard of people who have that disease, who their nerves, they can't feel, they can't tell if they're touching something hot. So now they touch something hot, but there's no nerves reporting back to the brain. So what would happen? Well, in reality, since your hand can't report that back, the nerves in the hand, you do have other things that will notice something is going on, right? And as morbid as it might be, you'll smell it, you'll see it. There's other inputs that will report back to the brain what they're seeing. Hey, the hand is touching something that's very hot and there's damage occurring. And the brain will decide what to do with that. Now, essentially, the brain is going to make the same decision. We need to move away from this hot thing that's damaging us. So what's the difference between the system working correctly and that triangle breaking down? We lose one of these inputs. The effective difference is that there's more damage to the hand. It was there longer, more damage occurred. So it's exactly the same in the car. If that triangle breaks down, it can't see or trust the input from the oxygen sensor. There are other inputs. There are other sensors that it's monitoring, and it will get back to the computer, and the computer will make the decision to dump more fuel. But what happens as a result of not having the correct input? More damage occurs. In this case, the catalytic converter, which is one of the most expensive parts in a vehicle, is going to have more damage done to it. So it's important to have this triangle in place and it working correctly. Otherwise, more damage occurs. So any questions so far? Okay, so now, one thing that's noteworthy here is this open loop, closed loop thing that you might have heard about. When a car first starts, it's in what they call open loop. Basically, the difference between these two is it's not really trusting these inputs. It's just saying, you know what, I'm going to just take my base programming and run with that. The problem is, without that triangle, without the true triangle in open loop, it's very sloppy, right? It's dumping a lot of extra fuel because it doesn't want to run lean. Lean is hot and more damage occurs. So it plays it safe, in other words, but it's not efficient this way. And there are reasons why that is, but basically once the system warms up, it can start to trust all of these inputs. The oxygen sensors basically come online because they have to be warmed to work. That's one of the reasons that it's in closed loop to begin with. So once everything starts to warm up and starts to work, now it can trust these inputs that are going to the computer, and the computer can make decisions with information that's valid. Okay, so let's go with, in a human body, you have the nerves that we talked about, and you have muscles, and you have the brain. So those three things in the triangle. In a car, the nerves are basically sensors. The muscles that move are actuators, and then the brain is the ECM. So it's the same triangle, there's different names: sensors, actuators, and ECM. So let's just go over some of these sensors. One of them is the coolant temperature sensor. Coolant temperature sensor is important because a car that is cold is not efficient. It actually needs that heat to atomize the fuel, to burn for combustion, complete combustion to occur. You need to get up to operating temperature. So how do we know that we're up to operating temperature? And time is one thing, but actually measuring the temperature is an important one. So the coolant temperature sensor reports back to the computer, and this is a two-wire sensor, so I don't want to get too far out into the woods. It's a negative coefficient type sensor, so as it heats up, less resistance type thing, and the computer monitors the voltage going to it, and you can test these things. All of these sensors have a way of testing them. So there would be specs provided. If you were doing it dynamically, you could check the voltage, or if you were reading scan data, or you can do it statically, which we're not a huge fan of, but you could check the resistance in this at given known temperatures to see how accurate it is. I mean, I've personally had sensors that when the car is warm, it's reporting that the car is cold. It just, you need to be able to establish some kind of specs. Okay. Another sensor is a manifold absolute map sensor, manifold absolute pressure. So this monitors basically the intake, they call it pressure, but the intake vacuum, right? It's an important one for fueling. When you push that gas pedal, you're opening that butterfly, removing the restriction that's in that intake, and the vacuum dissipates. So watching that is a good indicator is if you're pushing the gas pedal or not. If that engine doesn't have vacuum, then basically it's assuming that, hey, you've got wide open throttle there, and that air is just being supplied and being used by the engine. So we need to fuel accordingly. It's a 3-wire sensor. It'll have a reference voltage and then a ground and then a return signal that, again, you can monitor with a meter, oscilloscope, or scan data. And, there's specs on all of this type of stuff. Throttle position sensor. So this is, again, another important one. When you push the gas pedal, the computer wants to know that you're pushing it. It wants to know, are you pushing it a little? Are you pushing it a lot? Are you, did you just let go of the gas pedal? Should we cut the pulse width then? Because there are times actually where it stops giving the engine fuel, So throttle position sensor, again, has specs. Now, I do want to point out a couple of things. Static testing versus dynamic testing. I could take that sensor off the vehicle and I can use a meter and I can check it. I can actuate it and watch the voltage, watch the voltages on the meter, or check the resistances on the meter. But the problem is that's what they call a static test. A static test is when it's not in the system working. Now, in general, in auto, we are not a fan of static testing. We are a fan of dynamic testing when it's in the system working. And I want to give you an example. So on a scope, a throttle position sensor at idle, so right here is this flat line right here, it's just idling, which is typical throttle position sensor works on a 0.5 to 4.5 voltage. So it would just say at a roughly 0.5 voltage here, it's just idling. Now you start pushing the gas pedal, you can see the voltage start to rise, but notice it's not a straight line up because it's over time, it's graduated. So you're pushing the gas pedal, pushing. So over time, the voltage starts to rise and finally you reach wide open throttle. So now you're at that 4.5 volts roughly. And then you let go of the gas pedal and it starts to drop and then you're back at idle. So this is a traditional pattern on an oscilloscope. Now, Scott Shotton is, I think he's an instructor at Kishwaukee, but his main thing is he does mobile. He goes to a shop when they can't figure out what's wrong with the car. He figures it out and then he does presentations based on that. So he was working, this is an old slide of his, 1998 Caravan with a 3.3. And what would happen is this thing would intermittently stall on light acceleration. If you floored it, the thing was fine. But if you just kind of took off from a stoplight at a normal acceleration, intermittently, the thing would just die. So here's the other thing. There's no codes in here. I cannot tell you how many times customers say, oh, mechanics have a computer that they hook up to the car and it tells them what's wrong with it. If any of you guys come across one of these computers, I need one because I have not found a computer that just tells me what's wrong with the car. I have been forced to try to figure out what's wrong with it. This computer is saying, there's nothing wrong with me, don't worry about it. No codes present. So he goes through some of his normal testing, and one of the things he checks is the throttle position sensor. Again, the typical flat at idle, and then you give it gas. You see this little glitch here? So there's the glitch, and then it continues and it comes back down, and then it glitches in the same spot. Within the sensor, there's this little glitch that if you're on that for any length of time, the computer doesn't know what to do with it. It panics. It says, you know what, I'm not going to make a mistake here. My safe bet is just to stop. Now, since then, they've come up with limp mode, but, basically, I'm just going to shut off because I don't know what to do. I don't know what's happening with this throttle position sensor. It's not in my base mapping that it should respond like this. So I'm just going to shut off. So he found that using this oscilloscope dynamically, you would not have found this just with the part on the bench, just checking it on the side. So the other key thing is here, you wouldn't have even found this with a meter because of how quick this thing glitched. It was 25 milliseconds on a traditional slow takeoff, 25 milliseconds. It takes you 300 to 400 milliseconds to blink. So in the course of a blink, you know, this could have happened, whatever, 16 times. So this is a similar car, 99 Caravan, except this one stalls on deceleration. So when you let go of the gas pedal, you find the thing dies. And using the same oscilloscope, watching this traditional TPS pattern in the vehicle while it's running, you give it gas, you let go, and it's got like a short to ground type thing. And once it shorts to ground and the computer picks that up, it's like, hey, I'm just going to shut off. So there's that. Now, moving on to some of these things, the direct ignition system, you know, the ignition system of any modern car compared to points and vacuum advance.
Hey, Joe,
Yes.
before we move into that, there was a question in the chat regarding the TPS, the throttle position sensor. And it said, wouldn't a throttle position sensor basically give you the same information as the map sensor?
Yes, that is true, but try to think of that initial thing we were talking about, where if one of the sensors aren't reading, we need some redundancies. There are many, many inputs that are redundant, but that the computer constantly checks each one of them and compares them. And there's a term, something rationale, there is a term that, does it make sense that this is doing this because the other ones are doing this? So in order to know that one of them is off, if you relied 100% on the throttle position sensor and nothing else, you could never know that it's off, because you're just trusting that everything that it's telling you is accurate. So the reason how it knows is by comparing and contrasting to these other sensors. So there is a lot of redundancy built into this.
But it's purposeful redundancy.
Yes.
You know, yeah, it's a double check to make sure, you know, that if one system is reading incorrectly, it can go to a second sensor to see if that one is telling it the same information or not.
Exactly.
Okay, good, thank you.
And I should point out, though, that redundancy is not the only reason. So let me give you an example. When you have quarter throttle, 25% throttle at idle is entirely different as 25% throttle going down the road, as 25% throttle going uphill. So you need different amounts of fuel. Just because you're doing 25% throttle, you need different amounts of fuel. When you're at 25% throttle with idle, just in park, you need almost no extra fuel. It does not take very much more to raise up the engine to whatever 2000 RPM at idle. It takes a lot more fuel to go up a hill at 2000. So now you've got that speed density measurement of the map sensor. So it's not simply redundancy, they have purpose, you know, for each one.
Good.
So, does that make sense?
Yep, thank you.
Okay, so the ignition system. Ignition is obviously important. It's come a long way from the days of vacuum advance and points. Getting the spark at the right time is very important. If the spark is late, it's chasing down that piston and it's not really producing the power that it needs. And of course, if it's way too early, so getting it there at the exact right time is very important. And just mechanical ways of doing things just don't have that level of efficiency and can't react to the changing environment quick enough. So now you have a system that relies on an input of a crankshaft position sensor. So it knows exactly where the crankshaft is at all times, and it can adjust the spark based on all of these inputs, temperature, load, and when to send it. So you have to have this electronic system in place to be able to do that. By the way, waste fire, I mean, that's a whole nother conversation. These things fire one, and then it creates a circle and it comes back. So the traditional model you have in your head where the spark fires from the center electrode and then goes to that grounding strap, only happens on 2 of these cylinders. The other 2, the spark comes from the grounding strap and jumps backwards to the electrode on their events. So actually Ford, a lot of these manufacturers, like say for a 6-cylinder vehicle, you'll have 2 different types of spark plugs. The 3 that fire backwards will be iridium or something, and then the 3 that fire the traditional way might only be copper. So it's fine if you go to the parts store and they say, hey, there's 2 kinds and you buy all 6 iridium, but if you buy all of them copper, those are going to prematurely fail because they're firing backwards. But okay, I'm getting sidetracked, sorry. So wiring diagrams are important. This is just an example of how that ignition system is all tied together for diagnosing reasons. You need to check these inputs and then see if the computer is providing the correct output. Again, there are specs for some of these, you know, the ignition coil, primary, secondary, things like that. There are specs for them. You would really need scan data to check some of this. Okay, another input is a temperature sensor is important. We need to know the temperature of the air coming in for fueling reasons, spark reasons. We talked already about a crankshaft position sensor, so it can tell you exactly where the crankshaft is, so it knows when to open and close that primary circuit, and cause the spark to happen, you know, and fire the spark plugs. Okay, on oxygen sensors is another important one. Its name is a little deceptive because it actually is not watching oxygen. It's actually watching the ratio between the fuel and air that's coming through. For example, an event where spark did not occur, and now you have raw gas and air that left the combustion chamber, will basically be a neutral reading on this oxygen sensor. You would think, hey, there's a lot more oxygen here, so I should be reading, you know, a lean condition, but it actually is watching the ratio. But that I digress. So, but the main purpose is to watch that mixture and report back to the computer. So all the stuff that we've been talking about is before it fuels. We're going to, based on your throttle position and map input, we are going to put this amount of fuel, because we think you've got this amount of air coming in, but this checks it after. So it says, well, this is what actually happened, you know, so you need to start putting more fuel or less fuel in here based on what this input is. And as far as testing, this one's a little harder because there is no static test for this one. There is no just hook up your meter and see what it says. This does have to be on the vehicle working, and you can do it with the meter, but scope is obviously much more preferred. Okay, so far we've been talking about all these inputs that go into the computer. None of those things can make any change at all. So if there was no actuators on this car, it would simply be telling the computer everything it's seeing, and that's that. There's nothing that can be done. So we need to be able to make these corrections. Now, there are a substantially less amount of actuators. There are a lot more inputs that come into making these decisions, but a fuel injector is an actuator. This is something that the computer can control and put more or less fuel in the engine after each event. When it fires one time and that goes past that oxygen sensor, it can make now corrections. You let go of the gas pedal, it can make corrections. So it's pretty instantaneous, these corrections. But again, they have specs as well. But as you could tell, I'm a much bigger fan of static testing, or I'm sorry, of dynamic testing than static testing. Now, controlling the idle. Right, so back to we all remember the days of a set screw and using a screwdriver and setting that idle. But that was a constant, you know, you have to make corrections with that. Well, here you have, the car has the ability to set the idle to wherever it wants to now. You know, you press the air conditioning button, well, that puts a load on the engine because now you're turning that AC compressor. You turn the steering wheel, you're putting a load on the engine because of the power steering pump now is having to create that pressure. You know, these different load variances, now the computer can control it. So it can maintain the minimum optimal idle as these variables come in. And this just does that simply by letting more or less air bypass that throttle plate. So the plate's still closed, and there's a bypass, and this valve controls how much air will bypass that. If it needs the idle to go up, it will let more air go in. So EGR, I don't know how familiar people are with EGR or what it does, but when you're going down the highway, you don't need the full 2.8 liters, for example, that the engine might have. You don't need that full displacement. You need that for power, creating power at takeoff, but just cruising down the highway, you don't need that. So if you don't need all that displacement, you don't need all that fuel, the simple rationale might be, hey, let's just put less fuel in the engine when you're cruising at idle. But that's no good if you put less fuel, because now you've messed with that ratio and you become very lean. You can't have lean. Lean is hot, things will start melting. So you can't just put less fuel just because you don't need as much fuel. You still have to maintain that 14.7 to 1. So how they solve this displacement issue, how they reduce this displacement, is by letting an inert gas like exhaust that has already been through the cycle into the system, and now you displace that displacement. So now you don't have the full 2.8 liters. You might have half of that. Half of it's taken up with an inert gas that is just taking space. Now you only have to fuel for the half of the air that you're pulling in, so you can put much less gas there, and you'll be much more fuel efficient cruising down the road with the EGR valve open. Now, the valve is not an open and close type thing. It opens 10%, 20%, 50%. You know, it opens up different based on different, again, variables, conditions. So you need a series of things to be able to monitor it and then to open it at these different type of levels.
And Joe, just to clarify, EGR is exhaust gas recirculation, correct?
That's exactly right. It pulls from the exhaust. That's, again, considered an inert gas. It doesn't have the oxygen in it that will cause the lean condition. It's just fills in space. So exhaust gas circulation. Okay. There are other things that the computer can control. These are all considered actuators because the computer can turn these on through transistors inside of them. Relays is a whole nother topic. I mean, we could spend several of these sessions talking about relays and the importance and what they do and why you need them. But there's that. Catalytic converter. So the actual 14.7 to 1 ratio is perfect burn, complete burn. There's actually no emissions at 14.7 to 1. But you can never attain 14.7 to 1. There's just too many variables. So the computer is constantly trying to, by being above 14.71, below 4, it's just constant. It's just, you know, up and down, up and down. It never maintains it at any length of time. So as efficient and as clean as these new cars have become, you still need a way to clean the stuff that does get burnt either rich or get burnt lean, you know, and that's what a catalytic converter does. It cleans it up. And again, that's a whole nother topic of how it exactly works. And, you know, you could spend a lot more time on it, but that's just the basic thing, is that when the mixture comes through here, no matter how clean it is, it's not perfect, and the oxygen sensor will try to take in the harmful gases and expel non-harmful gases. Like it will basically turn the CO, hydrocarbons, and NOx into water and carbon dioxide. So now, one thing is, how do you know your oxygen sensor is working? So this is one of the few major shifts, is they put an oxygen sensor before the catalytic converter, and then they put one after. So on a 4-cylinder car, you could, I'm sorry, in a 6-cylinder car with 2 banks, 6 or 8 cylinder, you could easily have 4 oxygen sensors, because there's pre and then post cat. And then what the computer does, the rationale is, it watches, okay, well, here we were above 14.7, below 14. You know, we watch this constant change on the first oxygen sensor, and then we see if the second oxygen sensor sees a much less, you know, swing. This is the simple rationale that it knows that the oxygen sensor or the catalytic converter is working, is by watching the pre and post data. Of course, all of these sensors and actuators are tied together with the wiring that we were talking about. And you don't want to undervalue this as a problem in diagnosing. It's not simply a sensor. It's not simply the computer. It could be the wiring with an open, short, or unwanted resistance, and then the computer using that data accordingly. So everything's wired together. Now, as far as the 4- and 6-cylinder Fieros, they're similar. You know, I think there's a few differences. Art was looking this up and found things like the EGR, the fuel injection. Obviously, you'll have multi-port fuel injection on a 6-cylinder as opposed to the central fuel injection on the 4 cylinders. But a lot of it's very similar. The wiring is similar. Locations, where are these sensors? If you wanted to find one, you can, they get you the general area of where they are. This is another wiring diagram, but it's a little bit more specific. And I like it because it shows what is happening kind of inside, you know, potentiometers, things like that. So again, a helpful tool for diagnosing, trying to evaluate what's wrong. Now, as far as the term mapping that we used earlier, that's just what's inside this computer. It has just a bunch of if and then. If I see this from this sensor, this sensor, this sensor, then I'm going to make these decisions. That's what the mapping is. It's the if then under different scenarios, you know, at different speeds. So it has all of these variables, and it just creates like a virtual map. And it says, if I see on these 30 sensors, this exact thing is happening at this time, then I'm going to make the outputs exactly this. It just, you know, it simplifies it for the computer. So my buddy, you might have seen people at the track hooked up a laptop. That's what they're changing, is that mapping. My buddy, he had this car where he changed the mapping where when you push the gas pedal 25%, it didn't have a traditional cable, you know, like the Fiero might have from the gas pedal to the throttle. It had where it's just motors. You push the gas pedal and it would use a motor to turn that throttle plate. Well, he wanted it to be a little different. When you push the gas pedal 25%, he didn't want it to open the throttle plate 25%. He wanted it to open 50%. So basically you were wide open throttle when you were halfway down. I don't know why he wanted that, but to each his own. So, but it changes that mapping. That's the programming that he put in there. So not every car has the ability to do this, but it does seems like they are trying to, some of the sports cars, that you can hack somehow and change some of that to, but the problem is when you do that, you change the fuel efficiency. and they consider that a violation. So I know one company went out of business. I can't think of the name, but they would change the EGR and some of these other inputs and outputs. And it's like, hey, now it's not doing what we designed it to do from a fuel, an emission standpoint. It's polluting more. Yes, you get more power out of that, but it's polluting. So we don't want that to happen. OBD1 versus OBD2. Again, you could spend a lot of time on this. But basically, as cars started to become electronic, all of them had a way to interface with this, PCM, ECM, but they were all different. Ford, you'd pop the hood and do it a certain way, and you couldn't see the data. Chrysler had a different way, GM had a different, all these manufacturers had a different way. And then finally they were like, listen, we need to standardize this. You can have your own sidebar special thing, but we need to standardize this. We want the connectors in a very specific place on every vehicle, and we want very specific data, emission data, to come through on this port. So that's what OBD2 did, is it standardized it. You can go buy a scanner right now from a parts store for $50 that will work on every vehicle from 96 to present for the basic global data that they're required to spit out. So what this just, it stands for onboard diagnostic generation 1, and then of course onboard diagnostic generation 2, and I think they're working on a third one right now. But again, this is just so you can interface with the computer and see what it's doing.
Joe, there was a question that just came in. Do you have a recommended handheld scanner, a brand name that works well with the GM OBD1? Okay,
so OBD2, there is a much simpler answer to that. OBD1, there is not. There were only a few manufacturers who made them. Snap-on, the Snap-on brick, that's this picture right here on the bottom right. Believe it or not, at the time these were $3,000. You can find these for like $300 now. They're just obsolete, and they're no good to us in the aftermarket, so they're very cheap. But Snap-on or OTC are the OTC Enhanced Monitor 4000 are the only two that I know did OBD1. So there may be others out there. You would have to try to find it, but these are the only two. And you can, on eBay, you can find these for cheap. Definitely less than 500, but 300, I see them routinely. So, and they'll have a bunch of different connectors, like for Ford, Chrysler, GM, you could just hook up and retrieve. Now, the only thing is, the data is only that I'm aware of was on GM. I don't think Ford you had to have a breakout box for, and Chrysler might have had some early data, but basically these just became kind of code extractors back in the day, which and you're on GM, you can do flash codes. You can jump these two and retrieve the number that the computer is seeing. So I don't know if I answered that good, but
okay, thank you.
Now, in the beginning, which is kind of where the Fieros fall, there were not a lot of codes. Now you can have 1,000 codes on a car. I mean, there's so many inputs and so many outputs and so many ways circuits can fail. That there are a lot more codes, and this, it was a lot simpler back then. But I do want to make something very, very, very clear. Codes do not tell you what's wrong with the car. So the example I really like to give is people pull their car into AutoZone and they'll check the codes for free for you. If you have a 96 or newer OBD2, you pull in any AutoZone or parts store, they'll hook it up and they'll say, oh, you have an oxygen sensor code here. Okay, well, the first thing that people do is go inside and buy an oxygen sensor, right? You have an oxygen sensor code, you buy an oxygen sensor and you put it in. But the code said lean, you know, that the oxygen sensor read lean. Well, why is it reading lean? Well, the fuel injector could be clogged. The fuel pump could not be delivering the correct amount of volume pressure. I mean, there's a lot of reasons. The code is just saying, hey, I have a parameter here in my mapping. I'm supposed to see a range from here to here. It's supposed to click back and forth this many times per second, and that's not happening. That's all that code tells you. Now, nowadays, they do have very specific circuit codes, you know, so that will help you a lot. But I'm just saying,
school.
What's that? So, you know, the fact that you get a code is not indicative of, it's just telling you what the computer doesn't like. Now you have to figure out why the computer doesn't like it. So I just caution you to get a code and go change a part, you know. Now, given these codes, they do have flow charts. There are ways to get these flow charts. So you get a specific code 35 and you start following the flow chart. Here's the condition here, you know, do this. And then did it do this? Yes or no? Well, if it did, then do that. And this is supposed to help narrow it down. First of all, the code will give you possible causes, you know, oh, you're getting a lean code because fuel injector, you know, vacuum leak, you know. So then it will basically take all those possible causes and have you test them. So that's what a flow chart does. And every code usually has some flow chart tied to it. Tools of the trade. Now, you know, again, another thing we can spend a lot of time on. But basically, for me, the workhorse of any electrical is a test light. Okay, and we'll talk about the difference between these two test lights in 1 second, but a test light. And then you step up to a meter, and then a scope. A scope is just a meter. It's a simple voltmeter. Scope is a simple voltmeter, but instead of displaying the numbers, you know, this way, it shows them in a picture. But that is not the main difference, because you do have regular voltmeters that can graph, so it can create the picture for you, but that is not a scope. The major difference between a meter and a scope, which again is just a voltmeter, is how fast it is, the refresh rates, the sample rates. So this is almost live. This is an average. It will, I'm making this number up, it's definitely not this slow, but it will check every 10 seconds and then let you know. So in that case earlier with the TPMS, when you saw that glitch, yeah, that would have picked up the voltage went from 0.5 to 0.6, but it would have averaged it over time, so you wouldn't really see it. You know, so this is an average, and it's very slow when it checks. And the scope is very fast, but they're both just voltmeters. Anyway, these are the traditional tools. Now, although I am a huge fan of a test light, when it comes to this type of testing that's specifically coming from the ECM, PCM, you generally want to stay away from a test light, because the main power of a test light is that it pulls amperage, and that's the last thing that you want to do to a PCM is force amperage through any of those circuits. When computers are built, they have this smoke, this magic smoke that's inside of them, and when you use this tool, you release that magic smoke from the PCM. Okay, that was just mechanic humor. Okay, so this type of test light is supposed to alleviate that. It's supposed to be a high impedance, low amperage type thing, so you're not going to, you shouldn't be doing damage with this type of LED test light. But I just don't feel the value. I personally don't own one of these. Either I want the test light to do this, or I'm using a meter, which is this basically, but with, you know, a better version. So I'm a fan of, plus the 5-volt reference, it doesn't I'm just a fan of the three tools I think you should have is a traditional incandescent bulb, test light, a meter, and then a scope. So, okay. So I do have case studies, but they're, I mean, if you're interested, but otherwise, what is there any questions that I can answer for you?
No questions right now in the chat. We are A-okay.
Okay. So I have several different types of case studies. So let me show you, let's start with this one. Okay, I name all my case studies for the students. This one I call assume, supposed to be the case without proof. So it's a 2003 Chevy Suburban, and the problem with it is there's a check engine light. So obviously you hook up the scanner, and there are two codes: an oxygen sensor here code, bank 1, sensor 2, and then a fuel composition circuit low input. Now, although I just told you that traditionally you don't grab the codes and then start replacing things, this is a heater circuit code. This is kind of like a light bulb inside the oxygen sensor, and it's the heating element to get this thing cooking quick so we can get into closed loop. And they just burn out. They just burn out. So it's a 2-wire power and ground heating element light bulb inside the oxygen sensor. And when they fail, you have to replace the oxygen sensor. So the students looked at that code, and they basically said the fuse was good. You know, they checked the fuse at, you know, in the junction box. So they basically told the teacher, this is done in our service class at the school. And they told the teacher, hey, this car needs an oxygen sensor. And then he said, okay, what else does it need? And they pulled up the wiring diagram for the fuel composition sensor. But what is a fuel composition sensor? And not all of these type of cars have them, but you may have seen that flex fuel where you can buy, you know, regular traditional gas, or you could buy that ethanol or whatever at the gas station. So flex fuel vehicles are ones that you could put either one, because you cannot put either one in a traditional car. So this is a flex fuel vehicle. You can put ethanol in there, but there is a literal sensor that as the fuel flows through the sensor, it tells the PCM the percentage of ethanol that's, you know, that's in the fuel, so it can make adjustments, because the ethanol requires a longer pulse width on a fuel injection. You have to advance the timing more. They just don't, it doesn't create as much power, so the engine has to compensate for that. So anyway, they look up the wiring diagram, and it is a simple 3-wire sensor. Here's the fuel composition sensor. From the fuse, there's power coming into it. And then there's a ground. You need the ground for the thing to work. And then there's a simple wire that goes in between the fuel composition sensor and the ECM. So it's a 3-wire sensor. And the students rationalized, okay, well, it's going to have power, it's going to have ground, and then it's going to send a signal from this composition sensor out to the PCM. So that's what they rationalized, and they checked to make sure that it had power and ground. So how you do that is important. This is when I say that the test light reigns supreme. There is no better way of checking if a circuit is healthy than a test light. Now, I myself have several test lights, because just that little one is not efficient, or is not good enough for all the type of testing that you would require. It only pulls a 1/4 amp. This is a high beam test light, or a high beam headlight from a vehicle, and it pulls 6 amps. So this will let us know if this circuit is healthy. So they used this headlight, and they checked both the power and ground, and it pulled 6 amps and lit up the light healthy. So of the 3 wires from the sensor, the power and the ground, 2 of them are perfect. I mean, there's no, this doesn't lie. And this is what that fuel composition sensor looks like. You can see the fuel coming in and then the fuel coming out, and then that's it. It just does what it does, and that's it. Now, they checked the third wire at the sensor. It said 0 volts. So the power and ground to the sensor are good, but the wire at the sensor is saying 0 volts. They rationalized, like any person, is that the sensor is bad, right? It's not sending anything out to the computer. That's why the computer has that code. So they told the teacher that it needs a fuel composition sensor. Now, one thing I want to tell you about our service class is we don't charge labor. The customer only has to pay for the parts. And it's just the employees. We can only do work for employees. But you have to pay for these parts whether they work or not, because there's no markup for us to absorb that loss. You're taking the risk going in. So they asked the customer, do you want to do it? Now, the problem is this composition sensor, even with no parts markup, is $480. The oxygen sensor that they said is bad is $123. So at a shop, this might be a $1,500 repair, but at the school, it's only a $600 repair. So the customer was excited that at least they're getting this work at this discount, and they said, go ahead and do it. So they changed these parts, and same check engine light, same 2 codes. So they went back to the teacher, his name was Michael Foss, and said, hey, what do we do now? And he said, well, let's start with this fuel composition sensor. How does it work? And he said, they said, well, it's got a power, it's got a ground, and then it sends a signal to the PCM. And Foss said to them, well, how do you know that? And they said, well, we assumed. So he said, go find out how it works. And where you find that out is what they call the description and operation. And how it actually works is the PCM that we've been talking about sends 5 volts to the sensor. And then the sensor grounds that, and the PCM monitors that wire. So the power, this reference voltage comes from the PCM to the sensor. And then based on how often it happens, hertz, 50 to 150, it's either 0% ethanol or it's up to 100% ethanol. So he told them, go to the computer and see if that 5 volts is coming out of it, which it was. So essentially what was wrong with this car is they found 2 broken wires. One was for the oxygen sensor heater code, and one was for this fuel composition. So $1.06 and 2 butt connectors later, the problem was fixed. Now, insult to injury is this was my car and I had to pay for these parts. Yeah.
But hey, Joey, you got free labor out of it.
Yeah. So, and then anyway, this is what the pattern looks like then when the car is running. In this case, it's 58 hertz, meaning that there's 8% ethanol, which is what regular gas has anyway. So, okay. So there's the check engine light was gone. So
Joe, there's some questions that came in on the chat during that presentation.
Sure.
The first one was going back to the 1998 Caravan scenario. They said, what was the actual fix for that situation?
Oh, well, inside that throttle sensor, it had a glitch in it. Just from time, moving, it gets like a spot on it. And that's why when you did a fast acceleration, you passed it and the computer didn't see it and it was fine. But when you were just slowly accelerating, it would hit that spot, causing that glitch. So the correction was to replace the throttle position sensor.
Okay, all right. The next one is where can you get the flow charts for like the code numbers? I'm assuming you'll probably get that from the service manual for the vehicle, or I'm assuming at this point, a lot of that stuff is probably online as well.
That's what I was going to say is first, the service information from the manufacturer, which you can go to the manufacturer and buy this stuff. But on your, if you, for you guys, you would just, you have the book, you probably buy the service manual book for it, and it would be in there. Now, there are aftermarket service providers. The big three are All Data, Pro Demand, and the third one I can't think of, but those are the three. Motologic. Motologic's the third one. So you can get it there, but because of the age, you could definitely find that online. Somebody will have that full chart posted. Now, if you're looking for something for a newer car, you might be able to find it online, but you definitely want to get one of those aftermarket. You use one of those aftermarket service providers, but that's a yearly subscription type thing.
Okay, all right. The next question is, would an engine block heater help engine efficiency at startup?
Yes. I mean, you still are waiting for that oxygen sensor to heat up, but generally it's being heated up from the exhaust gases, which are less hot when the car is cold because the metal absorbs so much of it. But if you already have that metal warmed up, then it will. Now, I don't know how quicker, but yeah, it would definitely, it's all about getting that up to operating temperature.
Okay. Do you have any type of a price range for any of the scopes that you were talking about? There's something you can get at eBay used?
Okay, so the Snap-on scanner, not the one we talked about, that brick, has one in it. The Modus or the new one, the Zeus, I think, but they're very expensive, even in the aftermarket. Very expensive, meaning new, they're like 15 or 16,000. But that is a scanner / scope built in together. Now, for many of us, all these captures that I'm showing you here are using a Pico scope, which is a standalone scope that you use with a traditional laptop. And that is really the premier automotive one, the Pico. And those are 3,000 to 4,000. Now, they do have off-brand ones, but I personally have not seen success with them for very, very cheap. And also, for you guys, you might want to consider AES Wave sells a single channel scope. It's a real small little, like the size of a credit card, and it's a single channel scope, and they're relatively cheap, like $200. If you wanted to check things like your crankshaft position sensor, things like that. So there's a wide range just to answer the question.
Okay, all right. Bill, can we step back a little bit and post the poll question, that survey question regarding Fiorama while we go through some of these questions? Okay, all right, everyone should see that pop up. Feel free to just respond. Either you like the idea, don't like the idea, or you're indifferent regarding whether we should park Fieros by exterior color at this year's Fiorama. Again, just looking for input from club members on that. Thank you. The next question, Joe, is, are ECM failures at all common?
Okay, so I personally have found that more people condemn an ECM and replace it to find that it wasn't a problem than actual ECM problems. Yes, they fail, okay, but I don't think it's common. I mean, when there's a problem with the car, that's not the first part. It's like the last part. You need to make sure all of those inputs are there and the computer has the ability to do all those outputs. Of all the parts at the school that we've replaced over the last 8 years that I've been at this school, I've only seen 2 PCMs replaced, so.
Yeah, it seems like a lot of the go-to is, oh, there's something wrong with the ECM, just go ahead and replace it. As opposed to taking the time to go through each of the sensors and, like we did during the case study, actually finding out what truly is going on. Let's see. I think that was the last question, at least at this point in the chat. So I don't, did you have another another case study?
I have plenty. So whenever you guys want to
let's
cut it off.
let's do another case study, and then we can wrap it up.
Okay, so then okay, so here, this one, let me pull this one up. I call this one the Need for Speed O. It's a 2000 Ford Ranger with a 3-liter, 2-wheel drive. And what the problem was, he called and said that the vehicle has no speedometer. When he's driving, he has no speedometer. And the transmission will not shift unless you floor it and you redline the vehicle, and then it will force itself into the next gear. But it will, otherwise, if you just hold it up at 4,000 RPM in second gear, it'll just stay there until you either slow down or speed up. There's an ABS light on, dome light on, door jar light on. But his primary thing was the speedometer and transmission. So I should note that cars like the Fiero had one PCM, right? One ECM, but that's not the case anymore. The new Jeep Wagoneer that's out has 115 computers on it. Now they don't call them computers, they call them modules, but 115. The average, I will say, is 30 to 50. Okay. Now this car, this is a 2000, it's 22 years old. It's only got 4. Okay. And one of them is this gem. And that's where we focused because it had this P0500 code, vehicle speed sensor circuit fault. So I scoped the sensor, and this was the pattern that I got. And this is not recognizable to me. Now, I don't know every pattern on every car, obviously. And, you know, that was the intention of a different case study I had, is that you being able to retrieve these. How do you know what the pattern should look like? But in this particular case, I do know what this simple speed sensor should look like, and this is not it. So I unplugged the sensor, which there's only one on this car. Most cars have 4 now, at least one at every tire, and then, you know, there's some in the trans, but this only has 1. It's got ABS only on the rear of the vehicle. Again, it's 22 years old. So I hooked up the leads directly to the sensor with no plug on it. It is a permanent magnet type sensor. So when you spin the tires, it creates its own signal. It doesn't use a 5-volt reference. It just creates its own pattern. So this is with the thing unplugged, and this was the pattern that I got. This is what it should look like, but I'm only spinning the tire by hand right now. I start the car and the amplitude and frequency increase and the pattern's good. So if I would have replaced the sensor based on that code, I would have had the same problem. So it's not the sensor. This is 100% conclusive that it's not the sensor. So I go to the wiring diagram, and the 2 wires from that sensor go directly to this gem module, which is located behind the radio on the dash. So we pull the radio out and rip this dash down a little bit to get to this sensor, and I back probe the wires there, and I get the same crazy pattern with it plugged in. So, I mean, this is what it should look like, and then this is what it's doing when it's plugged in to this gem module. So here's what I did. I unplugged the gem module, and I checked the wires up in the front of the car by the radio with the sensor plugged in. So basically, I have an extension cord from the sensor to the computer, but it's not plugged into the computer. And the pattern's clean. It's only when I plug it into the computer that the pattern gets dirty. So whenever you suspect a computer, there is all the inputs that you have to check, but also equally important are the powers and grounds there. If you yourself suspect a computer on your car, you need to make sure that the powers and grounds are all there. This has 4 separate powers coming in, and 2 grounds. And we use the method with that headlight, you know, of pulling 6 amps to check, and they're all good. This computer has everything that it needs to send a signal out to the dashboard, but it's not doing it. When you plug it in, it gets crazy. So since the problem only happened when you plugged it in, and it had the pattern that it should, feeding this computer, I concluded it needed a computer, right? Speaking of. And we bought it. Now, luckily, this is plug and play. It doesn't have to be programmed, and it's cheap compared to computers now being $2,000. This was only a $300 computer. Put it in, same pattern. Now, the kids communicate differently than most of us, so I want them to see how I felt at this particular time, and that's why I put that there. But it was bad, so I didn't know exactly what to do. I got online. Online is a valuable resource, and again, checked if the sensor had gone straight to this generic electronic module, which it did. No plugs. I mean, I was kind of at a loss until I found that, in fact, they don't list the plug. The plug from everything outside the vehicle going inside to the vehicle is underneath the driver's seat. So I had to remove the driver's seat. This is a work vehicle. It's all vinyl. You know, it's a very stripped down model. But we had to remove the driver's seat to see this plug. And I wanted to see what the deal here was. And when I unplugged it, it was full of water. The whole thing was full of water. So the other thing that was really strange is you couldn't tell with the vinyl down, but this whole thing, this is not a great picture, was sopping wet. This was full of water. This whole thing was full of water. The owner wanted to know if this problem could have happened when he pressure washed the interior. So we ended up taking the entire interior out, seats, flooring, and everything. And like 2 days later, the stuff was still sopping wet. You know, you can see all the water. But basically, the solution was just drying out that plug and, you know, and putting it all back together. Now, the question is, what was happening? What I think was happening is that plug that you saw under the seat, when the GEM module was unplugged, it had nothing going through it except for that generated signal, very low voltage amperage from the sensor. So my scope saw that clean, but when you plugged in that module, it forced electricity through that plug, and it made the electricity in the water, you know, real dirty, and the pattern got real dirty that way. So anyway, just interesting stuff, I think.
Yeah. Yep. Okay. Any final questions for Joe before we wrap it up today? If so, go ahead and put them in the chat feature. Joe, I appreciate your time and talents. We definitely, you know, got a nice overview. Obviously, we could probably have a whole seminar on each individual sensor that was talked about today.
Yeah,
we'd be here for hours or weeks or months, believe it or not.
Yeah.
Yeah, right. So there was a comment in the chat. It says, so now you need to ask all your questions if they pressure wash the interior prior to the error occurring.
Yeah.
Wow. So, all right. So, Bill, do we get some responses on the poll question? Do we need to repost that, or we got some good data?
No, we got pretty good coverage, I think. We had 22 responses. So
good. Okay. All right. Appreciate that. Anything before we let Joe off the hook and we can talk about some events with Scott? Joe, feel free to stay on during our open forum chat section in case there's some additional questions that pop up. At this point, then, we're going to move to some upcoming events. Scott Campbell is going to talk about our next, our April, May, June, and also the 40th anniversary event. So, Scott, do you want to update us on some events that are some of the bigger events coming up?
Yep. Before we do that, we're going to go back to talking about the 40th because this just came through on Facebook as we were having a meeting. It has been announced with the dates and location. This just came through, as you can see, 44 minutes ago on Facebook for Midwest Fiero Clubs. The 40th anniversary will be in Pontiac, Michigan, July 12th through the 16th. So kind of mark that on your calendars and get that started up. More details will be to come on that. I am in communication with the Midwest Fiero Clubs on that and trying to get things, and I'm actually part of that planning committee. So it has been officially announced. So more details to come. Let's just put it that way.
Yep.
So give me a second here. And then upcoming things we got coming up. We're gonna go the April meeting. I know Jim talked about the
March meeting.
Yep, the March meeting, but the April meeting, we do have planned also. It will be more on OBD. It will be more in depth of OBD1 versus OBD2. It is with Ryan Gick of Sinister Performance. I know many of us have. Ryan's been in the Fiero community for a while, so he's done a lot of engine swaps, done a lot of retuning and stuff for a bunch of people. So he's really in depth into that. May we will have our spring for driving tour. We're going to go down to Starved Rock. We'll be meeting in the Naperville area and driving down there and having a nice day there. June we have our Dells Run. The Dells Run is going to be typical Dells Run, running Thursday through Sunday. Something we're doing different this year, we are going to have 3 groups driving up together from the Illinois area, Thursday, Friday, and Saturday. We will be posting those in the Fiero Focus and also Facebook when they're finalized. Basically, most of them are leaving at noon on Thursday and Friday, and then Saturday there'll be an early morning one heading up that way. Those are just being led by team members that are leading that way. It's just kind of everybody that wants to drive together, group in numbers, in case of mechanical issues, everybody can kind of be together and kind of make sure everybody's getting up there nice and safe. And then another one in June, about 3 weeks later, we have our N.I.F E on the road. We did this last year, going out to Minnesota to support our other groups in the Midwest Fiero Clubs. We went out to the Minnesotas, back to the 80s show. I ran a group of about 5 to 6 cars up there. We enjoyed the show, had a couple of good nice dinners and stuff like that. So this year we are going a little bit further. We're going to go out to Carlisle, Pennsylvania to join the Mid-Atlantic Clubs show. They do a big show at the Carlisle National event. We will be leaving here on Thursday, June 23rd in the afternoon. So anybody west of us that wants to join us can also join us in. We'll drive about halfway on the Thursday and then drive the other halfway on Friday morning. There will be about 5 to 6 hours each way. Plan on stopping 2 to 3 times for lunches, breakfast, whatever, gas fill up, stretch your legs, and then go out there. And then they have planned a pizza party, driving cruises, the show on Saturday, activities after the show on Saturday night. Sunday they have a breakfast with awards, and then we'll all be kind of coming home on your own. Different people have different plans afterwards. So hotels are booking up fast. You can email me directly. I'm the one that's running this event. If you want any further information, you can always just go to the N.I.F E, the Northern Illinois Fiero page, to the About section and find my email. And shoot me an email. My phone number is on there actually too. You can shoot me text messages. I can give you all the hotel information and stuff like that through there. So, but I know right now we have 4 Fieros going and 2 people going in personal cars. So we hope to have a few more joining us. Like I said, we had 5 last year going up to Minnesota. We're going to try to do this yearly, go and support our extra clubs. So we don't know what we'll do next year. Probably just be the 40th, but this year we are going to make a further trip out to Pennsylvania. So if there's any questions on the events, you can ask right now, or we can you can email me or Art at any time with them too.
All right, thank you very much, Scott. Something I wanted to bring up, Joe, during your presentation, you kind of briefly touched on catalytic converters. I'm sure you're aware that catalytic converters getting stolen out of cars is getting to be a reoccurring situation. I read a report recently where there was like 1,200 stolen out of brand new vehicles or newer vehicles in like every month. One of my coworkers who lives in an apartment complex went out to her vehicle in the morning on her way to work, and sure enough, it was making the horrible loud noise because it didn't have a muffler on it. It was just coming straight out of the exhaust pipe. She has a Mitsubishi Outlander Sport, and because of all the problems with getting parts, the catalytic converter is on a 3 to 4 month back order at this point. So she had to have a straight pipe put in by an auto body shop to at least get her car back on the road. When she called up the dealer, her vehicle, her Outlander Sport at the Mitsubishi dealer was 14th in line that was waiting for a catalytic converter. So as you were mentioning that, I thought of all of the rare metals and the reason that a lot of the catalytic converters are getting stolen now. So if you have a car outside, and typically it's, I think it's a lot more prevalent with SUVs because they ride higher than an automobile, but you definitely want to be careful of when you hear that kind of sawzall sound at 4 in the morning, you might want to go out and check to see what's going on with your car.
Yeah.
Open it up for chat now if anybody has yeah, there was a question, is there any way to protect your catalytic converter? I don't know if there's any specific thing that has come on the market yet that allows you to make your catalytic converter just a little bit easier or a little bit more difficult to get out from your car as a theft deterrent device. If anyone's heard of anything like that.
I did see an article. It was some little short clip on TV, and somebody made it was a steel plate that would bolt in around the cat. I don't recall what model car it was for or what cars they supported, but that was their solution. Make it harder. So the thief looks under there, says, I'll just go to the next car because this one's not impossible to get, but harder. So why bother?
Yeah,
of course, the easiest solution is to park it in the garage.
Yep.
With a guard dog.
Yep, that's for sure.
Joe, we did get another question via email, so I thought I'd just throw this one out there. It was Fiero specific a little bit. It says, and it's a little lengthy. Let me just read it to you. Reading ODB1 inputs on a Fiero implicitly means also including the voltage drop effects of 35-plus-year-old connections between the sensors and the ECM. Do you suggest that dynamic measurement should be made at the sensors as well as the ECM?
So I'm going to tell you that the simple answer is you start with whichever one is simpler. But yeah, if it's becoming a problem, then just because you're getting it at the sensor, you are going to have to go and see if it's actually making it into the computer, which is what that happened on that last case study where I checked at the sensor, but now I needed to go all the way back to the computer. So ultimately you start what's easier, but you might have to go directly at the PCM.
Okay, and there was a second part of the question. This person had a 86 2.8 liter V6 that had a bobble at part throttle that he eventually traced to a cold solder joint on one headlight motor. A GM fuel injection engineer I met said that the failing connections in motors and other actuators can cause spikes that ripple through and affect the ECM. Will a good recording oscilloscope help find such spikes?
Yes, that's to me the ultimate purpose of those, as opposed to a voltmeter, to see those spikes, and the refresh rate of an oscilloscope allows to see that.
Yeah. Yeah, that was something interesting that you pointed out, Joe, was the oscilloscope is like almost instantaneous versus the meters are like an average taken like every 10 seconds or something like that. That was a good good takeaway from today.
Oops.
Anything else? Anything, anybody wants to say anything? Feel free to unmute yourself and
Go ahead, John.
Yeah, I finally got it turned on. I wanted to ask Joe, what was that $200 scope you talked about?
I will, if I could still share. This is the only, I'm not advocating for this place. It's the only place I know where to get it, but AES Wave, they have, if you look under scopes, so you're able to see my screen, right?
it's just a blank screen right now. It's just your desktop.
Okay, then let me stop and do it again. How about now?
There we go. Yep, now we got it.
So AES Wave, we buy a lot of equipment from them, so you can get it anywhere. I'm not advocating for them, but one under lab scopes here, if you hit lab scopes, one channel scopes, they have these what they call U scopes, and we have these at the school. The students learn on them initially, and you could buy the basic set. This set is the basic set, but with things like just a few more attachments, so it's a little bit more. But you could buy this basic set for $184, but it's a single channel, self-contained type unit. And you can watch the video on it, but one of the real powers of the scope is when you have multiple channels on the same scope, you can compare and contrast the signals. So one of the case studies I had where the crank and cam were off a little bit, and as a result, the computer didn't know what to do with it. Well, with the single channel scope, you can't compare them like that. They're not on the same plane, if you will. But still, there's a lot of value in this simple scope. If your crankshaft position sensor, you would be able to see that. How it is. There's a lot of sensors that you would be able to, that throttle position sensor, you'd be able to do this on. So for the money compared to like these scopes, lab scopes, 4-channel is like the traditional automotive 4-channel scope. Even now, most are moving to 8.
Oh, wow.
But then, you see the jump from 200 to 4,500. It's worth starting out with the small one, so you can practice with it, play with it, so.
Okay, thank you.
Sure.
Thanks for sharing that, Joe.
Sure.
Hi there.
Another question?
Can you hear me?
Yes. Yep. Nick, go ahead.
It's not much of a question, but I'll contest to the value of a scope. About a year ago, over a year ago, I was troubleshooting a no start condition. And one of the ways I verified that the injectors were working was putting a scope probe on the injectors and watching the pulses that were supposed to be there. And yeah, so, things like that, I had no way of knowing how those injectors were working. So at least I had a good idea that it was working. Ultimately, it wasn't my problem, but at least it narrowed it. Said that that's not my problem. It was something else that was the problem. So
Agreed.
yeah, I mean, on those charts that you were showing earlier, I basically went through every single chart. And in my case, unfortunately, the very last thing that it suggested was the problem. So it took a few hours to go through all that charts, but they will work. They will help you out. So yeah, I would recommend a scope if you can afford it.
Excellent. Thank you, Nick. Any other questions or comments before we wrap up for today?
Yeah, Bill, when we were at Fiero Rama, you talked about that mini butane torch. Do you remember that? What was that? I have a different application for it though.
Yeah, I got it it was free at Menards some time ago. It was a little tiny torch. I mean, really tiny. And I used it, what I was talking to John about, I think at Fiero Rama, was I was having trouble getting my brake lines free. And they were just locked on there from being 40 years old. And I tried this I have a big torch. I didn't want to try that because there's too much going on in there, plastic and things. I didn't want to melt the whole thing. So this little thing though, I couldn't believe it worked. I just warmed up that fitting and it broke right free. It was great.
Is that what it's referred to as, a mini torch, or?
Yeah, John, I've got a picture of it somewhere. I can send it to you. It's the size of like it looks like a cigarette lighter. It's got a little torch tip on it. Little tiny blue flame shoots out the end. It's really
Yeah, cool. I got something going on, and I said, boy, I wish I had one of them torches Bill was talking about.
keep your fire extinguisher nearby.
Yeah,
At
right.
one time, you could get them for free. You buy, get them rebate. I got like 6 of them or something like that.
I got a bunch downstairs too, Nick. Yeah.
Right.
Throw one this way.
Yeah.
Okay, thanks.
All right, anything else?
Everybody's looking good too. All you guys, good to see you, man.
Yep, same here, Johnny.
You mentioned that one of the YouTube channels I follow is this Eric the Car Guy, and he had a thing about protecting your catalytic converter. And a lot of it was just welding a cage around it or just making it more difficult to find. I think he did mention one option that was off the shelf, but I think for the most part, it has to be kind of customized.
Mhm.
I wonder if manufacturers are going to start doing something about it. You know, it's a big problem. It would be easy for them to add a plate to protect it, to keep
They-
things away.
More heat in that area too then.
Yeah, understood. Right,
Yeah,
but they've got the engineering expertise to address that. So I would think they've got bright people. They could figure it out.
Of course,
Or
the problem with that
reflect
is everything you do to make it harder for the thief to get it also makes it harder for you to remove and repair it.
True.
Yeah, yep.
Yeah.
Watch, it'll probably become a dealer option at 100% markup. All right.
I did hear that article. They were recommending engraving your VIN number on the cat
Mm-hmm.
for whatever good that does. I don't know who's buying these things, if they really care if there's a VIN number on it or not, but I suppose if they found it, you could trace it back to your vehicle.
Yeah, yep.
Well,
All right, anything else? Again, Joe, thank you for your time this morning. We appreciate your input, insight, and expertise. Thank you for joining us for a Saturday, cold February Saturday morning. Hopefully you had nothing else to do outside today.
Well, thank you.
Yep. All righty. All right, thanks for everyone joining us today. We'll see you a month from now on March 19th for our next online Zoom meeting. We'll see you all then.
okay, bye-bye, everybody. Stay healthy.
Bye.
Hey, Scott, while you're still there,
Yeah,
you say there's 6 other cars going to Carlisle?
no, it's just 4 Fieros at the current moment and 2 personal cars.
Oh, okay.
So
And I just got to get off. I just got to get my stuff done. So
maybe 5 soon if Bill can get going.
yeah. John, did you? I was going to ask you. Did you get a hotel room, or are you looking for a roommate?
Me, at this point, yeah, but I got a buddy with a 58 Corvette that wants to tag along.
Oh, I love that car. I want to go with him.
Yeah, is he going to offer rides?
What's that?
Is he going to offer rides for us?
Oh, yeah. I'm going to tell him, I said, you ought to get rid of that and get a Fiero so that you.
He can join in if he's coming. That's fine.
Yep.
Okay, so unless we do a cot routine, my buddies,
I can sleep anywhere. I don't care.
we've done that, huh, Scott? At
So, okay.
Power Tour stuff. And then
I'll
how's
follow-
that?
I'll
Power
follow up with you, John.
Yeah. So,
Is
okay.
a Power Tour scheduled, Scott?
Yeah, more talk about that, John. I'll catch up with you. I'll call you.
All right, no sweat.
So.
Okay, Bill, I'm gonna pencil you in then.
Pencil me in.
Okay.
That's fine.
All right.
All right, see you guys.
Bye.
Everybody, enjoy the